Waalaikumsalam.
And good morning to all of you. Today we meet again, but in different class. Before we have learned to engineering, and today we will have class in physics, basic physics. And today my topic is density and elasticity of material. So before maybe your lecturer is Mr. Sugiono, right? And you already finished with him with the first session, and the second session I will continue to teach you about the physics. And we will discuss about density and elasticity for today's meeting. First is density or mass density. In Indonesia, we usually call as berat massa in Indonesia. But in English, you can say as a density, simply density or mass density. And every material in this world have a special mass density. Every material has different density. So density can be used as an identity of the material. For example, you have one hand of gold, and the other hand you have other material. For example, if it is iron. If you make the gold and iron with the same amount, for example, same volume, and you measure the weight with the same dimension, so the gold and the iron will be different mass. It's because the density of the material. Usually density in physics, we will give a rho as a notation. So if you find this notation in rho, it calls as a mass density. This is some example of materials density. Both was in kilogram per meter cubic, and the other is in gram per centimeter cubic. For example, water in 4 degrees Celsius, we can see that the density is 1000 kilogram per meter cubic, or 1 gram per centimeter cubic. This is the fluid. Water in fluid in 4 degrees Celsius is still in fluid, not in ice or in hard shape. The other is alcohol. It has 800 kilogram per meter cubic, or 0.8 gram per centimeter cubic. In this case, we can compare between water and alcohol. So the water is bigger density than alcohol. So if you mix water and alcohol in one glass or any shape, you will find that the water will be placed at the bottom of the glass and the alcohol at the upper side of the water, because water more weight than alcohol. The other example, this is for alloy. For example, mercury 13,600 kilogram per meter cubic. And the other is aluminum, ferrous or iron, gold, brass, silver, platinum, zinc, and any kind. And we can compare. This is water in 4 degrees Celsius, and if we raise the temperature For example, in 27 degrees Celsius, it means that in this room condition. So the density was much higher compared with 4 degrees Celsius. It reached almost 1,200 kilogram per meter cubic. And if the water was converted into ice in a hard shape, so the density was less than in 4 degrees Celsius, means that 920 kilogram per meter cubic. So water and also any kind of material sometimes has a similar characteristic. But maybe water is easy to measure because it is easy in water shape or fluid shape, and if we decrease the temperature, it becomes ice. So it's easy also to measure. So we can see that the density of water in different temperature was also different. For density in physics, we will use this equation. Density equal to mass per volume. This is mass in kilogram, and this is volume in meter cubic. So this is the equation of density. And every material in this world has a special mass density. So if you found some material, you can calculate, you can measure the length with the volume, and also measure with the weight measure. Then you calculate how much the density. This is using scale, weight scale. So you put your material at the weight scale, and you get how many kilogram. And for the volume, you must measure with ruler. For example, how much the length, the width, and the height, and you calculate the volume of the things. After you get mass and volume, you will get density. But please make sure the unit, this is kilogram meter cubic, so the density was kilogram per meter cubic. Then we go to the second characteristic of the material. It calls elasticity. Elasticity is the ability of object to return to its original shape after applied some external force. For example, I have this spring. This is from metal, spring metal. You can give a strength, so the spring will be make some elongation. After that, you can remove your hand. Then the spring will be back to its original shape, original length. So it means that at those conditions, the spring was in elastic condition. But sometimes, if you strong enough, But sometimes, if you are strong enough, maybe every day you exercise in gym, so you have a good muscle, you give a very strong elongation to this spring until some point. But after that, if you remove your hand and this spring was not back into this original length, it means that the spring was not in an elastic condition. So the spring was moved into plastic condition. So the plastic condition is condition where the material cannot back into its original shape. But if the material still back into its original length or original shape, it means that it is still in elastic condition. The other example is band rubber. I believe that you know this one. Sometimes if you buy some food, there is a packaging was wrapped with this rubber band, and also sometimes the color was many color. This is also the example of elastic material, elastic product. It's made from rubber, or we can call as a polymer, one of the polymer or elastomer. Rubber also has a high elasticity, so if you apply some force, then you remove your force, that the rubber can be back in return to its original shape. So these two products was the example of elastic product. And the elasticity was measured by some parameter. Usually we measure the elasticity and plasticity using this parameter. P, it means stress. F, it means force. And A is square length. For the material, for example, if you give a tensile stress to this material, so the A is the square dimension of this material. So it means that circle, squares of this circle. So the A will be in meter square. So this is the stress. Usually we call this P notation as a stress, not a mental stress, but material stress. We can get stress from F, force, per material square. And for the stress, we will three type of stress. First is tensile stress. So, for example, this material, if you give or you apply two direction of force, one is to the right side, one is to the left side, and you apply to this material, so this material will have more or longer length. So it's called as tensile stress. And the opposite, if you change the direction of the force, so like this, so my hand will be pressed this material, so the direction of the force will be meet each other. So the material, the result of this material will be pressing. So it calls as compression stress. And the last one is twisting stress, or we can also share as shear stress. This, for example, this material, I will apply some torsion like this. So in one direction, I will give torsion clockwise, and the other hand, I will give torsion counterclockwise. So this material will be shear stress in some point in this area, because I give a different direction of the torsion stress. So it called as twisting stress. So this is three types of stress. This is the illustration for tensile stress. I have the original shape of the material. The length is L0 or LO. After that, I give two type of force, and the direction is to the right and to the left. And the result of these two stress, the elongation of the material was longer than the original one. So we can measure that this is the L0 and this is the L. So we will have the delta L. So the delta L was get from L minus L0. This is illustration for tensile stress. And the other is compression stress. This is tensile also, see? And this is the compression stress. Oh, sorry. This direction was wrong. It should come upside, and this one is downside. So the material will be compressed into some length, and the length will be smaller than the original length. So this is called as a compression stress. This is wrong direction. It should be go upside. And the last is twisting stress. Imagine that this is the material, and we apply some torsion stress. So this area will be go to upside, and the force will be applied into the result. Result is go to the right side, and this area will be go to downwards, and the force will be go to the left side. So this and this was different direction, contrary different direction. So the material will become what is it? Yellowing. Sorry, not yellow. Yellowing. So the shape will be like this, or maybe in another direction. And in some area, for example in this one, there is some applied stress called as a shear stress. So between these two region, there will be some shear. So the shear will be called as a twisting stress. And mostly the stress, usually we can compute or we can measure how much the stress using stress strain diagram. Oh, strain is not yet explained. Then we have another parameter. It calls as strain, and the symbol is epsilon, like this. It's called as strain. So previously you have some material, and the length of material was L0. After that, you apply some force. And the length become L. So you will have the difference here. This is a delta L, which is the delta L was measure from L minus L0. So the strain we will have from delta L per L0. So this is the strain. If we see the unit of the L0 and L, for example, L0 was in meter or centimeter, L also in centimeter. So it means if delta L mean L0, this is still in centimeter. So if we apply the unit to the strain, it means that centimeter per centimeter. L0 also centimeter. So it means that strain didn't have any unit. It means that strain was dimensionless. So the strain is dimensionless. It has not any type of unit. Even you use a different unit, for example, this is centimeter, this is meter, you can convert into same unit. So the strain also didn't have any unit. It called as a dimensionless. So after we have stress, which is stress was have from P equal to F per A, and we have a strain. Then we also have another parameter to measure elasticity of material. It is called as modulus of elasticity, or sometimes was called as a Young's modulus. Young modulus usually using A symbol. This is the modulus of elasticity, or Young modulus was using equation A equal to P per strain. Sometimes using P, sometimes also using this symbol, this equal. This is called as stress also, like this one. And sometimes strain using epsilon, but sometimes using small e. It is also similar with strain, like this. So E capital equal to stress per elongation or strain. Usually E stands for elongation, or sometimes you can also say it as strain. So if modulus of elasticity was get from P per elongation or strain, which is the stress was get from F per A, and the elongation or strain was get from delta L per L0, because P was this F per A, and elongation or strain from delta L per L0. So E will be similar with this one. F multiplied by L0 divided by A multiplied by delta L. So this is the equation of the modulus of elasticity, and this is the basic equation of modulus of elasticity. Do you have any question for the stress, strain, and modulus of elasticity? Do you have any question? Did you get? Did you understand about the equation?
Yes.
Let's continue. And the unit of modulus of elasticity, we know that stress or P unit was previously kilogram. Newton per meter square. And what is the unit of elongation?
No.
Dimensionless. So this is didn't have any unit. So the unit of the modulus elasticity will be similar with the unit of stress. So the unit of A is Newton per meter square, because Newton per meter square was divided with 1. So it's equal to Newton per meter square. Because centimeter per centimeter was equal to 1. So it means that it is dimensions. So the unit of Young modulus and stress also similar. Also in Newton per meter square. This is the modulus of elasticity or Young modulus. The other, because we have 3 types of stress: tensile, compression, and twisting stress. So the modulus also have a 3 types. First one is Young modulus or modulus elasticity. It is for tensile stress. And the other is Pull modulus. It indicates the resistance to volume change with a negative sign, indicate volume decrease under increased pressure. So the Pull modulus was using B symbol equal to minus. Why minus? Because the minus indicate the volume was decreased. So minus delta P or delta pressure divided by delta volume per initial volume or the original volume. So this is the equation of Pull modulus. Or you can remove this equation. So we will have delta V per V0 or equal to V equal to minus delta P per Pull modulus. So if you want to find how many the volume change, you can use this equation. As long as you have this information, you can find in catalog, you can find or searching in the internet about how many the Pull modulus of any material. And also, in some cases, we also use the K symbol, which is the K symbol was called as compressibility. So the K is the index of the compressibility of the material. K was equal to 1 per B, 1 per B, or equal to delta V per V0 divided by delta V. So equal to this 1. But 1 per B. So this is will change. This B will change to the contrary shape. The delta V per V0 per delta P, or delta pressure, or delta stress. So by using K, so it's called as an index of compressibility of material. And then the last is shear modulus, usually using G symbol, G capital symbol. It equal to how stress in XY direction. It means that we have three Cartesian direction. We have X, Y, and Z. It means that if it is in an XY area, so the range of shear strain also in a same area. If this is in XY, it should have same. This is using XY. If this is using maybe XZ or ZA or any kind of combination of the Cartesian, so this is must follow. So G is equal to tau stress divided by your shear strain. Sorry. So the equation will be similar actually with the Young modulus. Young modulus, stress per strain. Shear modulus also same, stress and strain. But the shape of the force is different. This is for the shear force, and this is for the tensile force. This is a question. This is some example of modulus elasticity, modulus shear, and modulus pull. Sorry, this is in Indonesia. I will translate later. Okay, I forget. Besi, it means iron. Sorry. Fe, ferrous. It means besi. This is in Indonesia. Or iron. And baja is steel. Baja is steel. And the semi-symbol also, but it has different carbon composition. When we call steel, or when we steel has a carbon percentage less than 2%. So if the carbon percentage in iron, Fe, see like this. If this percentage of this iron was less than 2%, so it will fall as a steel. But if more than 2%, it will fall as an iron. kuningan brass, ya. Kuningan is brass. Brass. This is aluminium. Concrete, yeah. Concrete. Yeah, like this is. This one is concrete. This one is concrete. But this is wood panel. But this one is concrete. It means from mix of the cement, sand, water, and some small aggregate. It's called as concrete, or in Indonesia called as beton. And the other is, I don't know what is marble in marble, maybe. I'm not sure in what is in English. Maybe marble, maybe it's a high hardness stone.
Yeah.
So the stone has the surface hardness was very high. So the surface hardness was very high. In Indonesia, we call it as a marble. Maybe it is called as marble, or I don't know what is the exactly in English. So it has a young modulus and modulus B. Shear modulus is not measured because some of the this mark, it cannot be measured because some material, for example like concrete, beton, it's made from more than one component. It has a cement, water, sand, aggregate, and any kind. So it's difficult to measure the modulus of shear and modulus of wood. So it's difficult. Granite, nylon, this is the polymer, usually in some clothes. Nylon. What is human bone. Yeah, tulang is human bone. Our human bone has a young modulus approximately 15 multiplied by 10 9 times. 10, what is in mathematics? 10 pangkat 9.
Power by 9.
10
Power
4
by
by 9. Yeah. 10 4 by 9. This is our pool, human pool. Has young modulus 15 multiplied by 10 4 by 9. And the modulus shear is bigger. It's 80 multiplied by 10 4 by 9. This is water, alcohol, mercury, and this is hydrogen, helium, and carbon dioxide, and many others you can find in this website. So if you didn't found the number of the modulus, it means that it's difficult to measure. For example, water. How to measure the tensile stress of the water? We cannot. How to
compress.
How to tensile of the water? It's difficult. That's why for water there is no young modulus. Also, no shear modulus, but it has a pull modulus because we can compress the volume of the water. But usually the compression of the water was incompressible, for example, for the water, because it is an incompressible material. Water is incompressible material. It means that if you give the force to the water, he will transfer into any area with the same value of your force. That's why, because water or any kind of fluid has a incomprehensible condition, we can use as a hydraulic system. Hydraulic system, usually using in heavy industry. For example, to lifting car or some any transportation using this hydraulic system, and sometimes it's using water or any kind of fluid, for example oil. It can use water or oil, but usually in industry not using water but using oil, because water was very corrosive material to iron. So if you apply water for the hydraulic system, so the mechanism will be easy to corrosion. That's why using oil. Oil is less corrosive material. And this is the table for tensile strength. No, not only tensile strength, tensile, compression, and shear moment. This is for tensile, this is for compress, and this is for the shear strength. You can see some of the material, for example, iron, steel, brass, aluminum, concrete. What is batu bata? Brick. Yeah, brick. Brick. This is brick. Marble, granite, wood. Many type of wood actually. It is for pine. Cemara is made pine wood. Nylon and also human. Okay, let's go to the stress strain curve. This curve using to explain how many stress and elongation while some material was applied some tensile stress. So this diagram was called as stress strain diagram. you can see the vertical axis was stressed usually using this symbol or using P symbol. And the unit was Newton per meter square. And the horizontal axis was elongation or strain. It is dimensionless unit. And we can see some line. And the segment of line we have A, B, C, and D. And this is the breakpoint. When you conduct some experiment, in tensile experiment, for example, this material, you apply the tensile force. So initially, this is 0. Initially, the force will be increased. Also, the stress and the elongation will be increased. So when you apply the tensile force, the force will be increased and the length of your material will be increased. That's why the line will be linear line like this, from 0 until A. When you reach the A point, you continue, you give more force, so the shape of the line will be changed until P. So the line not linear line but non-linear line. So this is like parabolic line in a small way from A, B, C. So the B was called as the, usually in some catalog it's called as yield point. So the B is sometimes used as a yield point. And because the force from 0 until A was increased with a linear line, so if we divide, take one portion of this area, the vertical was stress of P and the horizontal was elongation. So the this line we call as so this line, if you compare between the vertical and horizontal stress per elongation, what will you have? Stress per elongation was equal to
Modulus.
modulus, right? So this line was the Young modulus. So this line is Young modulus. Because if you compare between vertical and horizontal, the vertical was stress and horizontal was elongation. So the equation will be equal to Young modulus. And Young modulus only measure only from 0 until A. After A, Young modulus is missing because Young modulus only in this area from 0 until A. That's why the area between 0 until A is called as the elastic area. This is from 0 until A. So this is the elastic area. After that, the characteristic of the material will be changed. area will be changed. So this area was equal to plastic area. It means that if you give force, zero with stress 1, stress 2. It means that if you give force or stress no more than stress 1, I mean that in this area, after that you remove your force, your material still continue return to its length because it's still in elastic area. But if you apply force more than stress 1, it means that in this area, more than stress 1, so it will be from A until break point. After you remove your force, your material will not return to its length because it's already reached the plastic area. So this is the limit of the force or stress. If you apply force or stress below stress 1 and you remove your stress or force, your material still returns to its basic condition. But if you apply force or stress more than stress 1, that material already move into plastic condition and it will not go back into the original length or original shape. This is the maximum stress or maximum force you can apply to the material. For example, stress 2. That's why this is usually called as ultimate point, or sometimes just simply called as tensile stress. If you searching in internet or reading a book for the material, sometimes called as ultimate point or sometimes called as tensile stress. This is the maximum force you can apply into any kind of material. After that, you can see that the curve was decreased until your material was free, until this material separate into two pieces, and this is the break point. So this is the natural condition of any type of material. If your material was reached the ultimate point or tensile stress, if you want to make your material break, it no need higher stress. It's only need smaller stress. It means that after you give your strength until ultimate point was reached, so if you continue to give any force, you will feel that your force was less higher after you reach this ultimate or tensile stress. For example, maybe you ever found some thin metal or alloy and you bending. The first time you bending, you will give maybe more effort, but after you give many kind of bending, after that immediately you will feel your hand will be give smaller effort until your material was cracking. It means that the first time you give bending, you will increase your force until you find the ultimate point. After the ultimate point was reached, then if you want to break your material, you no need higher force, but you need less force when the ultimate point already reached. That's why if you bending material, after that you remove your head and the material cannot back to its original shape, it means that your material already in this area, not in this area. But if you remove your hand and your material still return to its condition, so it's still in this elastic condition. So when the material not come back to the basic condition, you have to aware, is it already reached the ultimate point or not yet? Because this area was wide, maybe still in here. So if you want to break the material, you need more higher force. But if you already reached the ultimate point, so you just continue simply give the force less than the ultimate point. This case sometimes was happen in the road. Maybe if you go to somewhere using your car or motorcycle, maybe sometimes there is some accident, usually for heavy truck. Many times I see that sometimes heavy truck was break the shaft, the tire shaft, sometimes the broken. So the garden, in Indonesia we call it as a garden. Sometimes the garden was broken, the shaft was broken, and sometimes the broken truck happen when they didn't carry many material, or sometimes it's empty. They didn't carry any luggage, but the shaft or garden was broken. It's many times happen. If the truck was broken when they carried many or heavy material, I think it's normally. But sometimes they didn't carry any kind of anything, but they got broken and the garden was broke. It means that the garden or the shaft already reached the ultimate point. Maybe before they loading too many luggage in the carrier truck. So because they give overload luggage, so the ultimate point or tensile test was reaching. But fortunately, maybe while they transport the shaft, but until they unload their luggage and return back to go home, because the ultimate point was reaching. So with the empty truck, they driving. Sometimes the road was bumpy, sometimes the road was any hole. They hit some hole or they hit some bumpy road, and the shaft was broken because the strength of shaft was much decreased. Sometimes it happened with no loading of material. Previously, I also confused why this truck can broken the shaft in empty condition. But after I learned this characteristic of material, I know the answer. That's why maybe in a previous transport, they carry overload material. That's why you cannot carry overload luggage in your car. For example, you drive motorcycle with 4 of your friends all in one motorcycle. So maybe some parts of your motorcycle was reach the ultimate point. Maybe the shaft of the tire, maybe the suspension component, maybe already reached the limit. And while with your 4, including you, and your maybe suspension will be damaged. Or maybe it's you can go to your friend's house with a safely, but after you go back, you just driving alone.